Today I'm going to talk to you about changes in momentum. I'm going to show you this equation here, how to use it, how it applies to real life situations, and the importance of crumple zones on cars. So, first of all, it's important to know for your GCSE, you do not need to memorise this equation. You'll be given it, but you will need to know how to use it. So let's imagine there's two situations. First of all, let's imagine there's a van here with no crumple zone. I'll explain what a crumple zone is in just a minute. So let's imagine I've got this van here. Apologies for my awful drawings. But let's say I've got this van here and it hasn't got a crumple zone. Now, a crumple zone is a part of a vehicle which is specially designed in order to crumple upon impact in order to make the crash last for a slightly longer duration. And we'll see why that's important in a minute. So let's imagine this van has gone out of control and it's going to smash into that wall there. So let's say this van is 2,000 kilograms and it's speeding into that wall at a speed of 10 meters per second. When it hits into the wall, let's say it's a really firm wall, it will just come to a halt. So what we need to be able to do is we need to be able to do this calculation here. So first of all, remember, momentum is mass multiplied by velocity. So either the greater the mass or the faster an object's going, the greater its momentum. So for this one here, the force at the beginning is the mass, so 2,000 multiplied by its final velocity. Now its final velocity, as it's hitting into the wall and coming to a stop, is going to be 0 meters per second. So it's going to be 2,000 times 0, take away 2,000, because the mass hasn't changed, even though it's coming into the wall. The mass times the initial velocity, which is 10 meters per second. Now the time it's taken, let's say this whole collision, it took 1 second. So it took 1 second for it to come to the halt. So the whole thing would be divided by 1. Okay, let's just simplify that. So 2,000 times 0 is 0, and then 2,000 times 10 is 20,000 divided by 1. So the force is minus 20,000 divided by 1. The answer to that is just minus 20,000 newtons, because I've just divided by 1, so it's just minus 20,000. Now notice it's a minus number. This is because the force is in the opposite direction to the driver. Now, that's a huge amount of force to be put onto a person, which is the reason why a lot of the time people get really badly injured or killed in car accidents. Now, this car didn't have a crumple zone. This van did not have a crumple zone. Let's see how it would be different if this one had a crumple zone. So what we'll imagine now is we'll have the exact same van. So as a result, it's meant to be the same, even though I'll probably accidentally draw it a bit differently. It's meant to be the same. So again, we've got 2,000 kilograms just as before. Again, we're smashing into the wall at the same speed of 10 meters per second. But now this one has a crumple zone fitted. Now what that means is it's designed to kind of crumple upon impact, making the time of this collision last for longer. So let's say instead of 1 second, this collision lasted for 2 seconds instead. Let's just see the mass behind that then. So the force is going to be, so that's the mass, which is 2,000, times the final velocity. Again, it's coming to a halt, so its final velocity will be 0. Take away, take away the mass, which hasn't changed, times the initial velocity. So all of that so far is the same as the first instance, because we've got the same van. Now the difference is this time we're dividing by 2 instead of by 1, because it took longer. What we then need to do is this. 2,000 times 0 is 0. Take away 20,000, just as before, this time divided by 2. So it's going to be minus 20,000 divided by 2. Now minus 20,000 divided by 2 equals minus 10,000 newtons. So can we see this one has got half of the force acting on the person. Remember, this has got the minus number because the force is acting in the opposite direction to the motion of the fan. It's got half the force acting on the person. So by having that crumple zone, which increases the amount of time the collision occurs for, we are giving this person a much better chance of being able to survive. This is why crumple zones and seat belts are used, because they prolong the amount of time the collision happens for. Therefore, the change in momentum is, the force exerted upon the person is much less. That is how to use this equation, and that is changes in momentum. Thank you.